So now we have our instance. It's like we have our model, it's like we built the model, but then remember, after building the model, you of course need to train it. And what are you going to train it on? Well, of course, you're going to train it on that array X of the two independent variables in the training set. And of course, we already got this variable X right after importing the dataset. All right? And so, very simply here, we take again our object k-means, from which we're going to call the fit method. And this time, since we're doing unsupervised learning and we don't have a dependent variable, well, the only variable that we have to input here is, of course, our array of independent variables, x. All right? And that's it. That's how you train the k-mean algorithm, and we're going to train it, therefore, for all the numbers I going from 1 to 10. Great. But now, remember what we want to do? What this whole cell code is for? Well, we want to plot the elbow method, and so now that we train k-means, well, we have this value of the within cluster sum of squares. And so what we have to do here is take our list of those within cluster sum of squares and add the new one, which we now have because we just trained our k-means model. So let's do this. Let's take our list first, WCSS, and then to add an element into this list, well, we need to use the append function, there we go, in which we have to, of course, input what we want to append, and that is the within cluster sum of squares. And as we said before, the within cluster sum of squares is given by an attribute, which is not a method that you call from your object, but a value that you can get, right? And that attribute is called inertia with an underscore. And so to get it, you call your object first, k-means, then you add a dot, and then you call the attribute itself, which is, as we said, inertia. So you will find it appear here, there we go, with an underscore, inertia. All right? And that's it. That's all we have to do in this loop. So let's recap again. For each of the number of clusters I going from 1 to 10, we first build our k-means model, then we train it on our array of independent variables x, and then, because we have trained the k-means model, then we get this inertia attribute, which is exactly the within cluster sum of squares for this particular trained k-means model, and we add that value thanks to the append function in our list of within cluster sum of squares, WCSS. All right? You get the loop? So now, because this loop is over, let's go back to the main code. And now it's very easy. We just have to plot everything. So first we're going to plot the values on the x-axis and the y-axis, right? So to do this, we call our pyplot module, which has a shortcut plt, and then from which we call a function of the pyplot module, which is plot. Okay? And then in this plot function, we need to specify two arguments, which are first going to be the values that are going to be on the x-axis, and then the values that are going to be on the y-axis for each of the values in the x-axis. And so, first, the values on the x-axis is of course going to be our range of values going from 1 to 10. And so, that's exactly what we have to input directly, meaning the range of values going from 1 to 10, right? But I go up to 11 because the upper bound is excluded. So that's for the values on the x-axis. And then, in the second argument here of the plot function, well, we have to enter the values of the y-axis for each of those values in the x-axis going from 1 to 10. And well, we already have those values. That's exactly what we got thanks to this for loop here. And that's, of course, our list of within cluster sum of squares, WCSS. All right, and that's it. We could already plot this now, but let's make a nice graph. So then let's just give a title to this graph. And to do this, well, we call our pyplot module again, from which we're going to call another function this time, which is title, and which will give a nice title to our plot. So let's, for example, call it, in quotes, the elbow method. All right. Then let's give a nice label to the x-axis. And to do so, we call our pyplot module again plt, from which we call another function that is x-label. And then in the parenthesis, you enter in quotes, well, the label you want to give to your x-axis. And so, since in the x-axis we have the numbers of clusters going from 1 to 10, then let's call it number of clusters. As simple as that. Then let's copy this, because you guessed that the next step is to enter a y label. And so here we only have to replace x by y. And so, since on the y-axis we have the within cluster sum of squares, well, we can enter here for this label WCSS, right? Everyone will understand what this means. And finally, we're going to use a last function to make a nice plot of everything we implemented here. And that function is again from the PyPlot module, so we start with PLT, from which we're going to call this show function. And we don't have to specify anything in this show function. And there we go. Congratulations, you made your manual implementation of the elbow method. So now we can just relax and run the cell to visualize our plot. So let's do this, and here we go. That's the elbow method, giving for each numbers of clusters from 1 to 10, well, the within cluster sum of squares. And so now, the only question that we must wonder is, what is the optimal number of clusters? And I remind that this is the elbow itself in the graph. And so here we could wonder, is this the elbow or is this the elbow? And the best answer to that is this one, because that's after this point that we have, the least descending slope, right? Here it's a big negative slope, then a smaller negative slope, but not the smallest. And then here after this point, we have the smallest negative slope, okay? And that's where you'll find the optimal number of clusters. And for this particular elbow here, well, the number of clusters is exactly 5. And that, my friends, is the optimal number of clusters. So we got it, and therefore we're ready to now train the k-means model on the dataset by entering this time the optimal number of clusters that we just found, and which is 5. So we're basically going to do exactly the same as we did here in the loop, but by entering this time not a loop variable, but exactly 5. And therefore, my friends, I'm going to ask you, please try to do this implementation step before me, because you now know exactly what to do, and plus you know the optimal number of clusters. So please do it first, and then of course we'll do it together in the next tutorial. And until then, enjoy machine learning!